Hello guys, this is Ankit Dane and I will go to show how to design a G+5 story building on eTabs software. So I am preparing this video for uploading on YouTube. As you all know, I completed 60% of my training conducted by Skylab free during the Corona lockdown. Okay, so I just joined that training. With, uh, I have been joined the training for uh, 10 days and I daily watch the lectures on eTabs and SEB on Skylab uh, website. So if you want to learn eTabs and SEB for free during this lockdown and COVID-19 pandemic, so you can also log in and register on Skylab. I am preparing. I am making that video because I 60% of my training I have also completed. So the 40% is remaining. So my last assignment is to make a video on the project of any building and design that building on eTabs. So I need to send that video to Skylab for completing my training 100%. Okay, so I am preparing that video and I will publish it on YouTube and I share the link of this video to Cam Scanner and submit it. This is the last stage of my training, so therefore I am preparing that video. So let's start. Okay, so as you can see there, G+5 story I have taken, okay, to design on a tab, 3 bias along the x direction of 5 meters center center, 3 bias of along y direction center center. This is the plan of the building, okay, 3 bias in x, 3 bias in y, you can see, and beam size we taken as 300 by 400, column size is 400 by 400, slab is 150 thick, thick, the M25 grade of concrete we have taken, and Fe415 steel rebars we uh, provided there. Live load of 3 kilonewton per meter square, earthquake zone 2 we have taken. Okay, so let's start it and get open etabs and click on new model and click on use built-in with setting metric SI Indian. This is the code for steel IS 800 2007, IS 4564, select IS 4564 concrete and click on OK. Now we click on custom grid spacing and click on added grid data and click on display spacing, and our spacing in X direction, as we can see there is our spacing in X direction is 5 meter. Okay, 5 meter spacing in X direction, 4 meter in Y direction. So 5 meter and then 5 meter and then 5 meter, and here is the along y direction is 4 meter spacing. Okay, so let 4 meter 4 meter 4 meter and click on OK. Now I will edit the story data. So number of story we have G plus 5 means where we have 6 stories of same height 3 meter. Okay, so we put it typical story height as 3 meter and click on OK. So you will see the grid are prepared already as we provided data in grid, edit grid data. So the grid is looking like that. Now go to define material and add the India, add the material. Okay, so again we loaded you, go to define materials and now we provide the uh, M25 concrete and Fe415 steel. So let's provide that both material. India. Okay, so first provide concrete and then Indian and M25 grade of concrete and click on OK and click on OK. Now provide the rebars. Okay, so click on concrete, then go to rebar. Okay, so we provide Fe415, therefore HYSD grade of 415. click on OK, click on OK, and click on OK. We provided both material. Now we should provide the beam of size this, and then the column of size this, and slab. So first we provide beam. Okay, beam of size 300 by 400. So click on define, go to section and frame sections. So add, click on add properties, click on concrete rectangular, and then name it as beam of size 300 by 400. 300 by 400, change it to M25 material. Okay, the depth is 400, as we all know, 400 provided depth, and then the width is 300 of beam. Okay, so go to modify show bar rebars, click on modify show rebars, click on here beam. Okay, change the grade of steel to HYSD 4 and 5. Change the cover, top and bottom cover. We provide 30 and 30 for both according to uh, IS code. We can provide 30 cover also, so it would be best to provide 30 and click on OK. All thing is OK, and then click on OK. So we and click on OK again, so that you can see the beam of 300 or 400 is defined. Now click on add property, go to the rectangular section. Now we provide the column size we have taken is the column of size, this you can see the column of size 400 or 400. So go to this, and grade is M25 as constant, and click on column 400 by 400, 400 or 400, 400 by 400, and then click on modify rebars, and click on column, click on HYSD 415, click on rectangle, and all things are okay. Then click on the OK. Okay, the we all take all value according to the code just already predefined it, so need to uh, edit that. Okay, so this is the column property. All things are okay. 400 column, and click on OK. So you can see the columns wide. We are not use the column 400 let if we need to edit any property of this, so how can we edit? So let me show you how can we edit. So click on column, and then go to the modify show property, and you can edit also name and any property also. So I will add it 400 by 400. Okay, and click on OK. So this name will change now, and our beam and column are defined now. Click on OK, and now we go to define a slab of thickness 150 mm. So go to define. For that, go to section property, go to slab section, and add new properties, and slab of 150 mm. Okay, and then click on M25, grade of steel, shell thin, and then slab of 150 mm, and all things are okay. Let click on OK, and slab is defined. Okay, now we are going to uh, draw the members on this grid. Okay, so for this, first click on the all story bottom left, bottom right side, and click on left vertical menu bar. You can see quick draw beam option, so click on quick draw beam. The window is open here bottom left side, so click on that, and you can change it to moment. You can change this to the property. Let first I provide the beam section, so click on beam 300 400. For providing beam, you can select this whole area. Okay, so like that you can provide beam in all stories simultaneously. Now we should provide columns. For that, click on elevation, click on A, and click on elevation. Now I am providing the column of 400 by 400, and click on the column of any story. That column automatically uh, apply to all stories because we click this is bottom. This is I selecting all the columns. As you can see now, all columns are selected. If you want to see the extruded view, so for that you can click on extruded view. Here you can see, click on that, so you can view the extruded view of that model. Okay, in that model you can see, you can check out that any member is not left, or you can check out how if there is any member who left, we forget it. Okay, so but there is all is okay, and we can continue. Now let draw the slab. Okay, so slab, I click on this menu, quick draw slab. Okay, and now in bottom left menu bar, click on slab 150 mm as we define. Go to first plan for defining slab. Okay, click on left window and go to click on plan. Okay, left side should be in 3D. Now for quick draw slab, go to the slab and click on slab 150. Okay, so now you can draw the slab like for selecting that all slab blocks one by one. You can see the slab is provided to all stories. Now click on escape, and now go to the bottom story, go to the zero level. The level is shown and there z equal to 0 phase. We don't need to provide the slab at the bottom story for, so delete it. Before deleting, remember to select this one story option and select all the stories, or skip that again, one story option, and then select the slab of bottom story one by one and click on delete. So you can see only bottom story slab are deleted now. So now we should provide the joints, the base, the columns to be rigid at that bottom side. So let provide the assign the joints to the column base. Okay, so select all the joints of base story and then go to assign, and then go to joint, go to restrain, and click on this fixed support, apply, and okay. So now you can see there, this is your fixed support. At you can see if your column is fixed now from every, all column are become fixed at their base, so building is fixed on the ground. Now we going to define the load. Okay, on over on the slab and columns, slab beams. Okay, for that let's go to that property, the layout and properties. So live load of 3 kilonewton and earthquake zone is 2. For that we should design. So first we know that slab is taking the load. So slab having, let we assume the 1 kilonewton per meter square of self weight of plastering and tile materially. Okay, finishing is exerted on the slab. So for that first slab, first click on all story option and then click all slab one by one. Okay, just all slabs are selected now, and then go to assign. Assign, this is a shell kind thing. Shell, you go to shell load and go to uniform, and go to uniform, and then we provide dead load of 1 kilonewton per meter square in gravity direction. Okay, so that you can see the load is applied now. Well, now we provide the live load on this slab. Okay, the live load of 3 kilonewton, that is shown there. The live load of 3 kilonewton per meter square. So I am providing select, for that select all the slabs go to assign, go to shell loads, go to uniform, and then click here on live load, and we provide 3 kN per meter square live load. Click on apply and OK. So both load are apply. If you want to see the load are apply or not, so select any one slab and right click and click on loads. You can see uniform load of dead load 1 kN per meter square, and second one is 3 kN per meter square. So okay, you can check it out from here. Now we provide the load on slab, dead load, and live load. Okay, the self weight of column and slab beam, that software automatically considered. Okay, we don't need to provide the structural members, self weight of structural members. Okay, so now we providing the load of exterior wall. Okay, so exterior wall load comes on the exterior beams only. So for that, first select the exterior beam. I am selecting the beams one by one. The exterior beams, this is all exterior beam is automatically selected for all story because we are check it out on all stories, therefore. So all the exterior beams are selected, then go to assign. Okay, then go to frame loads because we select a frame, go to distributed, go and the uniform load should be applied on the beam. So how much load will apply on that? So the wall load on the exterior beam is nothing but the load of wall or weight of wall. Okay, so how can we find that? We know that the density into volume is the weight of any material. So the density of wall, brick wall is 19 kilonewton per meter cube. We are providing brick wall, and into volume. Volume is what? The height, width, and depth of wall. So what is the height of wall? First we take thickness of wall. Thickness of wall we provide 0.23 meter, and then click into, and then into we provide height of slab, height of wall. So what is the height of wall? The height of wall is 3 meter, but we should subtract the depth of beam from that because beam covering some area. So beam, the depth of beam is 0.4 meter. Okay, bracket, click on apply. You will see the software automatically calculate that, and the 11.3 kilonewton per meter load is of wall is extruded on the external exterior beams. So click on OK for that. This is a dead kind of load. Click on OK. Okay, so the our beams are subjected to, you can see beams are subjected to 11.3 kilonewton per meter uniform load. Now we provided dead load and live load. Okay, now you can see how this shown. Okay, how it apply. Now we go to uh, we are going to apply earthquake load. Okay, so for that, go to define. First we should define load pattern. Okay, so load pattern of we provide seismic or earthquake load. So click seismic, right, seismic, and here select the seismic, and here select the code IS 193 This is the code of earthquake for Indian standard. According to Indian standard, click on OK. Add, okay, for add this, add new load pattern. Click on again pattern. Seismic load is already added now here. Now as you can see, there is earthquake zone 2, the building situated in the area of earthquake zone 2. So how we can apply that earthquake zone? So for that, select that seismic load, and then click on modify lateral load. Now we are not giving any eccentricity in x and y direction, only we are applying the earthquake from x or y direction. Okay, now the zone factor is zero point 0.1 for zone 2. Okay, so I will select zone 0.1 because for zone 2 the zone factor is zero point 0.1. For zone 3 the zone factor is 0.16. So for our case it is zero point 0.1. Soil type is moderate. Okay, so soil type 1 meaning is soil is very soft, second means soil is moderate soft, and third is rocky soil. So over we take two important factors. Is one, because our structure is not very important. I mean, it is not a very important building. It is a normal residential building. So, and story is number six, and response reduction factor we providing three. Okay, and click on OK. So we applied, click on OK. We applied the earthquake load. Now we uh, going to generate load combination. For that, I will again elaborate you. Go to define, go to load combination, and add new load combo. Sorry, add no, as default design combo. Click on as default design combo, or here our structure is concrete frame design structure, concrete frame. Select concrete frame and click on OK. So you can see automatically the code according to IS 456, the 8 load combination are generated. Click on OK. If you want to see where is the code, where is our revised preference, is IS 456 or not. So click on design, click on concrete, click on view revised preference. You can see here our code for concrete IS 456 2000 is already selected. According to this code, the 8 load combination are generated. Click on OK. Now we provided all things. We provide earthquake load as the question says, earthquake load according to earthquake zone 2, the live load, all thing we are already done. Now the last thing we need to do is only to run the analysis. So for that you can directly run from this icon of play bar, or you can go to analyze and click on run analysis. Two option you have. Let me save this file. I save as sky. Let I save as sky labs Ankit assignment. Okay, so Skylab Ankit assignment and click on save. As you save, the analysis is running. So the system takes some time to analysis because it analyze members one by one. So over analysis has been done. Now here you can interpret your results. Okay, I'm not going to interpret your results because I have not much more time for that. Okay, our analysis is still our analysis is running, so therefore we should wait some. System take some time to analyze. Now I think it is analyzed. Okay, now if you want to check our structure is fail or not, if you want to check any member have failed or not, I mean our structure is safe or not. So for that, if you want to check is any member there failing or not, so for that going to design, going to concrete frame, and going to here start design check. So clicking on that, so every single members, each members are going to check whether they are failing or not. Check is done. So you can see here. Okay, the if any member, the color of any member is showing red, it means that member is very critical, in very critical condition and may fail. For that, if you want to check now the number of member failing, so for that going to design and going to click on concrete frame design and going to here verify all member passed. Click on that. As if I click on that, the warning is come on the screen. All concrete member frames passed the design check. It means our structure is safe, and click on OK. If you want to check the detailing, so click on detailing. You can watch the detailing of every members. Okay, or you can watch the model explorer on left side. You have all information about the model of all things. You can clicking on all things. You having the uh, uh, detailing of everything here. Okay, so our structure is safe. Okay, and if you want to see the how much reinforcement we should provide on every member, So reinforcement is, you can see in 3D. Sorry, it is hanging, I think so, some. So as I watch that column, so 1280 mm the reinforcement should required on that column, and the beam, as I watch that beam at center 347. Let increase the window. So as you can see, 347 mm square at bottom at center and 347 mm square reinforcement at top center. 516 mm square as at top left side and bottom left is 347. So you can see the reinforcement also. So my project is completed. I am preparing that video for Skylabs to show that I learn full video. So sir, thank for Skylabs to provide me free learning lectures, and it will be helpful for my future also. So thanks for that providing, and I hope that you will be satisfied with my video, and thank you for that. I stopping that video now. Okay, so I recommend you to join the free learning of Skylabs for ETAPS and SAP softwares. Okay, okay, let I click. I am stopping that